Today, on How It's Made. Bumpers. We embark on a collision course. Lighting gels and camera filters, color changers that help us see things in a different light. Steam-powered models. They'll transport you to another era. And candy canes. Their story is sweet and syrupy. With all the attention we pay to high-tech automotive components, it's easy to overlook the importance of a vehicle's bumpers. About 80% of car accidents are front or rear collisions. The bumper is designed to hit the other car's bumper and absorb the force of the impact, minimizing damage in low-speed collisions. Bumpers can be made of plastic, fiberglass, aluminum, or steel. This company makes steel bumpers. They start out as blanks, steel sheets just 2 millimeters thick. These ones are en route to becoming truck bumpers. A robot feeds each blank through a series of dies, 7 to 9 of them, depending on the bumper model. Each die stamps the blank to a particular shape using some 2,000 tons of force. This progressively forms the blank into the final bumper shape. Both the front and rear bumpers go through the same process, only the dies are different. The bumpers now travel to the next production area, where a worker clamps each one onto a specially designed cart. At this point, the factory paints certain models. These bumpers, however, will get a chrome plating. But first, they travel through a series of buffing wheels. The bumper surface must be impeccably smooth because the chrome finish magnifies even the most minuscule flaw. A computer-guided crane stacks the bumpers and maneuvers them through the chrome plating process. It first submerges the bumpers in several cleaning tanks to remove any residue that previous operations may have left on the surface. The company won't divulge what chemicals it uses to clean the steel because this surface preparation is the secret to first-rate metal plating. The first plating tank applies a coat of nickel to protect the steel from corrosion. The next tank applies the chrome layer. The factory uses the standard electroplating process. In the water and chemical-filled tank, it laces particles of the plating metal with a positive charge and runs a negative charge through the bumpers. This magnetically draws the particles onto the bumpers in an even layer. After a thorough rinse, the bumpers enter the inspection area. Workers scrutinize the chrome mirror finish under high-intensity light. Meanwhile, this machine pressure injects molten plastic into various molds. The machine's built-in cooling system hardens the plastic within seconds. Then out come the plastic components that attach to the bumpers. One of those plastic parts is the step pad that covers the top of the rear bumper. Once the pad's in place, a worker attaches a built-in trailer hitch and steel mounting brackets that also structurally reinforce the bumper. The front bumper goes down a different assembly line. A worker attaches a plastic trim that hangs down just below the bumper. Its aerodynamic shape helps direct airflow to the engine compartment. Next, 4 steel reinforcing brackets that also attach the bumper to the truck's frame. Finally, the last components, the license plate holder and fog lamps. Workers tighten all the bolts to a specified tightness. This ensures that the bumper and its mounting brackets will adequately absorb the force of a collision. Whenever a new model goes into production, The first few bumpers off the line go through a battery of tests to ensure they can withstand stress, vibration, and a certain degree of what engineers call crash energy. Other types of bumper systems use a combination of springs and energy-absorbing materials such as plastic foam. With either method, the goal is for the bumper to absorb the impact. In a low-impact crash, this should ideally confine the damage to the bumper itself, leaving the headlights and engine unscathed. Gels and filters can turn a bad scene into a good one. Technicians use them to color lights in the theater, enhancing the scene on stage. They also use them in camera work to even out a mix of color temperatures from different light sources. In both cases, they help make things picture perfect. These lighting gels can make any scene take on a different hue. They're called gels because they used to be made of gelatin film, but today they make them out of transparent polyester. They mix a batch of solvent, some dye, and some flame retardant chemicals. This produces a colored lacquer. They test the lacquer's thickness by pouring it into a brass cup with a hole in the bottom. As the lacquer drains out of the hole, they time how long it takes. If it flows too quickly, it means the lacquer is too thin, and if it drains too slowly, it's too thick. A steady flow means the lacquer mix is the perfect consistency, about as thick as engine oil. A sample of every batch undergoes this test because the lacquer's consistency is critical. If they don't get it right, it won't bond to the clear polyester. With the lacquer prepared, they load the polyester film into the coating machine. A big roller soaks up lacquer from a tray below and spreads it on the film. A thin bar on the roller evens the spread and scrapes off the excess. The lacquer dries in seconds. Every production run of the same color has to precisely match the last, so they regularly test the color of the lacquers on swatches of clear polyester. If gel colors are even slightly mismatched, using them together will make for a patchy-looking job. Differently colored gels create different effects. This orangey-red one will warm up daylight, so it's more like indoor lighting. That's an advantage in certain photography situations. Now in a test, they hold a gel swatch over a flame. The gel doesn't catch fire, proving that batch is ready for the hot lights of the stage and screen. Over at another station, they're working on a different sort of color changer, a filter that goes on a camera lens. They dip a sheet of special optical plastic in hot water and dye. The hot water opens the pores of the plastic, and this allows the dye to penetrate. When it cools, the color is trapped inside the plastic. The longer they leave the plastic in the dye bath, the deeper the color. They dye just half of some sheets to make filters that reduce the exposure of half the camera image. Filters made from a range of colors will help the camera's eye do what the human eye does effortlessly, adjust to different lighting conditions. They sheath the colored sheet in thin plastic. This prevents scratching as they cut it to size. These camera filters are practically ready for your close-up. All that's left is for the inkjet printer to brand them. similar type of printer gives the lighting gels the trademark stamp. And it's time to wrap things up. They slide a cardboard core into a machine that winds the finished gel sheet onto it. And a pneumatic ram pushes the roll of lighting gel into a plastic bag. Now these filters and gels are ready to show things in the best light possible. When they build live steam models, they're reconstructing history. These working steam models take us on a nostalgic journey, back to the days when steam ruled the rails and the roads. And for hobbyists, firing one up is a great way to let off a little steam. Add a little water, light some fuel for the boiler, and it's full steam ahead. This mini replica of a 19th century road locomotive is really a blast from the past. It starts with the boiler. A hydraulic press punches a piece of brass repeatedly. This action turns the brass into a cylinder. It's a process called drawing, and it also strengthens the metal. From a flat piece of brass to a cylinder in a few minutes. They trim the ends of the cylinder. Then they brush solder paste onto a brass cap and slot it into a holding device. They brush the paste onto attachments inside the cylindrical boiler. Then they press fit the boiler and cap together. The capped boilers travel through a furnace which melts the solder paste, fusing the caps to the cylinder. They polish the brass to give it a nice sheen. Then they solder copper pipes to the boiler. These pipes will expel the steam as it powers this little locomotive. They trim the flywheel, which has been pre-cast. The flywheel will smooth out the engine's firing impulses so that it runs more evenly. They screw the flywheel tightly to the crankshaft. They check the sliding action of the piston and its cylinder. Then they attach the assembly to the engine frame and the crankshaft. Lubricating the piston assembly enhances its sliding action. They test it with compressed air instead of steam. They check how it functions and look for leaks. Once it passes inspection, they install the front steering mechanism, which will control the steam model's front wheels, while the larger wheels at the back will push it forward. Steam machines are usually rear-wheel drive. A wire called the drive band moves the energy from the flywheel to the rear wheel. They hook up the steam model to the compressed air tank once again for a final test run. And it looks like this model is ready for some action. All it needs is a canopy to provide a little shade. They punch a rib design into a little steel roof. After they give it a nice paint job, they attach it to the model. Now you have a model that's geared to bring back yesteryear. This model will also take you back in time, but in high style. It's a luxury touring car. They install the piston cylinder assembly a little lower on this roadster and fire it up. Each of this mini steam models is a tribute to the original. They'll all help you relive a time when vehicle ignition meant lighting a match and really burning some fuel. In the 17th century, a German choirmaster decided to put a new twist on the sugar stick. He had some bent into shepherd's crooks as a special treat for his choir, and that's believed to be how the candy cane was invented. But it wasn't until more than a century later that they earned their stripes. Today, candy canes come in different stripes and sizes. They start by cooking up a big batch of sugar, water, and corn syrup. Next, they prepare a mix of starch and flavoring, like peppermint or strawberry. As they blend them together, the flavoring binds to the starch. They empty the flavoring mix into the middle of the syrupy slab. Then they feed the whole thing to a machine that uses shovels and a plunger to fold the batch repeatedly. This distributes the flavoring evenly. Cold water piped into the shovels and the kneading table cools the candy cane mix, so it takes on a stiffer consistency, perfect for the next step. It's over to the automated pullers. These pullers stretch the candy around a metal post. This action aerates the candy, turning it white. There's enough here to make 3,200 candy canes, but there's a lot more work to be done before this job is licked. They roll the candy into a fat log while heaters warm it, making it pliable enough to shape. Next, they roll strips of red-colored candy. A worker then stretches and folds the red batch to widen the strip. They arrange 2 of the red strips on either side of the cylindrical mound. It weighs over 45 kilograms, so it takes 2 workers to carry it to the next machine. It's called a batch roller. Cylinders roll the candy thinner in a process that will dramatically reduce the diameter of the log to candy cane dimensions. A torch moves across the candy to keep it pliable. Then the sugary batch travels between wheels that slim it down even more. Now it's a rope of candy, and it exits in a wave-like fashion. This gives it some slack so it doesn't stretch as it moves through another set of wheels. The candy rope moves through 2 angled belts that twist it, and a chain of knives cut the twisted rope to candy cane size. This production has been perfectly choreographed. One misstep and the job would hit a snarl. Here, a roll of cellophane unwinds, and a device wraps it around the striped candy stick. Pipes blast hot air to shrink the cellophane on the ends of the canes. Once they're wrapped, these candy sticks finally get their crooks. This machine, called a crooker deck, bends the ends of the candy sticks to turn them into canes. A bracket brush overhead secures the canes gently because although they're pliable enough to bend, they're still a bit fragile. There's a camera inside this robotic arm which allows it to spot the candy canes on the conveyor belt and pick them up 2 at a time. places them in cardboard packages, filling them up by the dozen. It takes about half an hour to make a box of candy canes, and they're sure to come to a very sticky end in a lot less time than that.